Hey guys, welcome back. And let me just start this video by saying anyone who's been watching these that I'm sorry, it's been a while. I just got really far behind with work because of multiple different things, but we'll get into that maybe in the future. But let's just continue from where we left off. So we created a map grid. Essentially, we gave a cell size and everything so that we can adjust and scale everything down into this Boolean array so that we can detect collision and see where everything is. So we're going to just create some variables, two public ints, the map width and the map height. And we're not going to set it equal to width and height. That's not, the map width and map height are going to be the scaled version of our map essentially. So map width is going to equal the width times our cell size. This will scale everything up to make everything in our grid be the right size essentially. And you'll see what I mean when I visualize it for you. And then height times height times cell size. And so now I'm gonna make this visualized for you. So we're gonna make a public void render, just so that you guys get a really basic idea of what's happening right now. So what we're gonna give as an argument is a shape renderer, and just call it render. And now what a shape renderer is it's just like a sprite batch, essentially for rendering, but it works the same way. You have to call render.begin and everything. However, instead of drawing sprites and stuff, this is going to actually just draw shapes, which are pre-built functions or methods. So we're going to create a little for loop for int x equals 0, and just stick with me here, I'll explain everything in a second. While x is less than MapGrid dot length, MapGrid dot length, and then increment that. Oh, that's why it wasn't giving me options. A little typo. Okay, and then same thing, but for a y coordinate. Int y equals 0, while y is less than MapGrid. MapGrid actually x dot length, in case we have different sized, like an askew array. So the reason we do this is it's going to grab each individual cell. So if one row is 6 long and the next one is 5 long, it'll know that because it's checking, okay, what's the length of this one? Oh, this one's 6 long. Oh, this one's 5 long. So that's just in case we run into any of those situations. But we shouldn't with the just rectangular width and height here, but it's good practice. And then what we're going to do is render.line. And this is going to take two arguments, an x and a y, and then another x and a y. And this is asking, okay, give me my starting coordinates and my end coordinates. So it's going to start at, if we said 0, 0, and it's going to finish at 10, 10. So it'll be from 0, it'll be like a diagonal upright. So like from here up, you know? So what we're going to do is, actually, we're going to go back into our main class, and we're going to create a shape renderer really quick. Public shape renderer render. And we're going to need an instance of our map grid. So just do public MapGrid grid, import those both, and then we're just going to initialize our render. So render equals new shape renderer. And then we have to do render.set auto shape type, and then put to true. This just makes it so it's easier for the renderer to know what it's drawing. So it'll automatically find it. And then we're going to do grid equals new map grid. And we gave it two arguments, the height and the width, so we'll do 100 by 100, we'll say. And then we'll do render.begin, and then grid.render, and we'll give it the render, and then render.end. This is just some old stuff. We're just doing the same thing as the batch, except for doing it with shapes. So let's go back into our map grid. So if we did from 0, 0 to 10, 10, it should be like a little diagonal. Let's just make sure that's working. Yeah, if you, whoa, my bad. if you look in this corner here, you'll see it's just a little diagonal. 10 by 10 is very small based on the scale we're using. But so now we're going to visualize what exactly this map grid looks like. So we want to draw all the lines of our map grid, which X and Y are mapping out essentially, because while it's less than the length of it. And the length, I'm pretty sure we gave, what did we give it? We gave it 100 by, we gave it 100 by 100. So this is actually, it's not 100 by 100. Well, it is inside the map grid, but really, if we multiply that by 25, we're getting 2,500 by 2,500, which is the actual scale of our game. Because if it was just 100 by 100, it'd be really small. So if we're going to be able to do this, we're going to go from, we'll say, from the first x, from x comma 0 to x comma y. Because that's going to draw from the bottom left, because it starts at 0, 0. And then it's going to go to the next spot, which is 0, comma 0 for y. But it'll be up here eventually. But here's the thing. That's just what it looks like. This is kind of hard to explain, but that's just what it looks like inside the map grid, the Boolean. It's got to be scaled up. So we got to multiply that by cell size. We got to multiply all this by cell size so that we can really understand what's happening. And once we do that, let's see what we got. We're going to debug this. And we get a bunch of up lines, right? So we're just mapping out what exactly this looks like. And then if we copy and paste that all, then we just got to realistically take the inverse, but we're not going to be lazy. We're going to understand what's happening. So now we got to draw it upwards. But in order to do that, we got to go from, hold on. We have to go from the bottom left to the right while going upwards. And this is kind of hard to just understand. But as we go on, you will understand this. So if you're like, oh, I'm so confused, I got to go back, just stick with it. And this is going to be kind of a longer episode, but you really just got to stick with it and try to understand it here. So this is going from, the first line is going from the left. So if we look at it, if we look at both this and the code, I'll just keep the top part here so you could just see how it's going. So it's going from x times cell size. Well, the cell size is 25, so it's from here to here. And if you look at our box, we had them by 50 by 50. So these are going to make up 4 cells once we're done drawing everything. So let's just finish drawing it. So it's going to go from 0 to y times cell size. And then it's going to go from, oh wait, no. Yeah, so I'm hoping you guys understand this, but again, like I said, if you don't, that's not a big deal. But let's just continue. So from x to x times cell size, y times cell size. I didn't really look into this, but we're just going to see how it looks. Yeah, okay, so if you look at this, these are our cells. All of these are our cells. So what our collision handler is going to be able to see is, oh, there's a wall, 1, 2, 3 above you, and 1, 2 to the right of you. So when we're in our game and we're up right here, it's going to say, well, once we're right here, we're technically in these 4 cells. But once we're right here, like as soon as we cross this line, we're in this too. And it's going to say, be careful, once you hit this next line, there's something there, and you shouldn't be able to go through it. And that's what we're going to try to accomplish. Okay, so now that we got our cells all drawn out, we're going to need, this map grid is going to need to have all the entities. So we're going to make an array list of these entities, array list of collidables, because everything is a collidable, collidables entities. Okay, oh, it's just collidable, I think. Yep, it should just be collidable. Yeah, and then we're just going to initiate it. Entities equals new array list of collidables. Collidable. And there we go. And in order to put this into our map grid, yeah, we have an array list. That's great. But we need to be able to put it into our map so that it knows where everything is. Right now it doesn't know where anything is. We just have a Boolean array of false. So public void add to grid. So we got to add something to the grid. And what do we want to add? A collidable, because that's what our list is made of. So entities dot, what's wrong? Entities, oh, spelled it wrong. Entities dot add e. So now every time we create a new object that's able to be collided with, we're going to add it to this grid so our player just can't walk through it. And this will help for when we're shooting things, etc. Like, we won't be able to just get shot and not be known. We have to know where we are. And this is going to make a very easy way to know where we are inside this big grid. But if we were to scale it down, so if you look at this, you might be thinking, well, that's not very efficient, because once you cross this line, it thinks you're obtaining this whole box. And that doesn't help us, because then it's going to tell us to stop moving right there. But there's two options we can do with this, and we're going to explore our options in a future video, but I'm just going to let you get a brief insight on it now. We could say, once we're here, allow to move only once you reach the very next spot. Or we can scale all these boxes down so small that you won't even be able to tell the difference, because there is going to be a slight gap between them because the boxes will be so small, but you won't even be able to tell. But that takes up a lot of power. We gotta keep this efficient. So there's many ways we can go about doing this. So if we added our entities to this, we have to be able to check its grid position. So we're going to go back into our collidables, and we're going to create a vector. We have a vector, and we're going to name it grid position, because we need to know where it is in the grid, not just where it is in space. And grid position equals new vector 2. And I want you guys to really think about this. I don't want you to just be copying code, because I'm a self-taught programmer up until college, obviously, but I spent a lot of time just copying code and not really understanding concepts. So what should I set this grid position to in the vector? Like, what are its parameters in here? I hope you gave it a shot, and I hope you really were able to come up with something. But we're going to take the X position, and since that's a scaled up version, we're going to divide it by the MapGrid cell size. Therefore, if we're at 25, that's 1 comma whatever in the MapGrid. So if we're at 1 comma, or we're at 25 comma 25 in just open space, then it's going to assign us to be in 1 comma 1 in the MapGrid. And we're going to do the same thing for Y. Oh, whoops. Y divided by MapGrid.cell size. And we obviously need to update this. So grid position, be careful with this. Grid position.x equals position.x divided by MapGrid.cell size. You got to be careful. You can't set MapGrid equal to position. That's just not the way vector multiplication and division works in Java. You got to do it piece by piece. So grid position.y equals position.y divided by MapGrid.cell size. And obviously we have, so we were able to program the information the MapGrid needs. However, we need a way to get it. So public vector2 get grid position. And then we're going to return the grid position. Simple as that. Now we're going to go back into our MapGrid so that we can create a update method. And what this update method is going to do is it's going to tell us where we are true in the grid and where we are false. So we're going to create a for loop for int I equals 0 while I is less than entities dot size. So we're just iterating through the collidables, and then we're going to increment as we go through. So this is what we're going to do. Entities dot, all right. This is going to be a confusing piece of code right here, so I need you to really understand what's happening. We're going to call the MapGrid. We're going to give it 2 arguments. The MapGrid has booleans. So what we just did is we were able to get the grid position. So we're going to grab the grid position dot get I dot get grid position dot x. So wherever it is in this grid, we just grabbed it. And we're going to do the same thing. Get grid position dot y. Let's pull it down. We're going to set that equal to true. And my fault, these are vectors, so we got to cast them to ints. So I hope you understand what we just did. All we did was grab the grid position. So the grid position is just the position scaled down by this cell size. And we set it to true. So now if we start moving, we will be true in this map grid. But it's going to get a little bit, it's going to get even more difficult because we also have, this is true, but if I move to the right, it's still going to be true and my new position is going to be true. So now we got to create a vector of an old position. So if I were to run this right now and I were to call update in my main method, which actually let me do that with you right now. So we're just going to do, this is pretty important, so we'll put it right under the grid.update. So now as I go through here, as of right this second, this cell right here is true. If I go up, this one and this one are true. We'll focus on getting all 4 true in a little bit. We're going to create little nodes. But these 2 are true now. And then as I move up, these 3 are true now. So that's all the time I have to make in this episode. But for the next one, I want you to try to make it so as you move, your old position is false and your new position is true. A little hint, you're going to need another vector in the collidables, and I'll just start it for you right now. We'll call it old position, and you're going to need a new method in the map grid, but I'll tackle that in the next episode, and I'll see you guys in the next one.